If your physics exams is coming up and you are still worried to how to derive the kinematic equations of motions because your school book is looking terrifying with those complicated graphs, so this video is for you. In this video we will learn about how to derive these three kinematic equations of motion in simplest algebraic methods. So grab the pen and let's score full marks. The three equations of motions or the three kinematic equations of motions are V equals to U plus AT, S equals to UT plus half AT square and V square equals to U square plus 2AS. Remember that these three equations are valid only when the acceleration is constant. That is, velocity, the change in velocity is equal in equal interval of time. That is constant acceleration or uniform acceleration. Because if the acceleration is non-constant or non-uniform, then these three equations will not remain valid. Now, in these equations, V refers to the final velocity, U stands for the initial velocity, S is the displacement, A is constant acceleration or the uniform acceleration, and T is the time taken to change the velocity from U to V. The initial velocity was U and the final velocity is V. So, the velocity changes from U to V in the time interval T. Now let us derive the first equation of motion, that is V equals to U plus AT. For this we will start from the definition of acceleration. Acceleration A is equals to change in velocity divided by the time taken to change this velocity. Change in velocity divided by time taken to change this velocity. Change in velocity can also be written as final velocity minus initial velocity. Final velocity V minus initial velocity U. And the time taken to change this velocity is T. So there will be T. This is A. Or if we move T to this side, here it is in division form, so in this side it will be in multiplication form, that is AT equals to V minus U. Now if we move U to this side, it will become addition, that is AT plus U equals to V, because in this side U has minus sign in front. So if it is moved to this side, the sign will change to plus sign. Now rearranging this equation, we can write V equals to U plus AT. V equals to U plus AT. Rearranging this line, we can get this. So this is the first equation. Now for the second kinematic equation of motion, we will start from the definition of velocity. We know that velocity is equals to displacement divided by the time taken. Displacement by time, this is, or the rate of change of displacement, this is actually the definition of velocity. From here we will get displacement equals to velocity into time. Velocity into time, because see, time is in division form here. So if this is moved to this side of equal sign, then it will be in multiplication form. We have done this. Now here velocity is different, because in the starting the velocity was U, but finally it becomes V. So which value will we take? In this case we will take average velocity. We will take average velocity. Now another thing is that you know that the formula for average velocity is total displacement by the total time. This is the formula for average velocity. But in case of constant acceleration, there is another formula, that is average velocity is equals to initial velocity plus final velocity divided by 2. This equation or this formula of average velocity is not valid for non-constant acceleration or non-uniform acceleration. This is valid only when the acceleration is constant. So in this case we can use this formula. So displacement is A. See, S is the displacement. So in place of displacement we can write S. V average velocity is we have told that for constant acceleration average velocity is initial velocity plus final velocity by 2. So initial velocity u plus final velocity v divided by 2 into time taken is t. So we have got this. Now in place of v we will write this equation. This using equation 1, that is in place of v we will write u plus at. So S equals to u plus, in place of v write this u plus at by 2 into t. There is a t, so t. This we have write this using equation 1. This equation 1, v equals to u plus at, in place of v we have write this. Now this will be 2u. Now this t will be here it is bracket, so t will be multiplied with both the terms. No, at first write 2u plus at by 2 into t. This is S. Again this t will be multiplied to both 2u and at, that is 2ut plus at square divided by 2, or 2ut by 2 plus at square by 2. We have written this denominator separately in below both the numerators. So it will be ut, 2 will be cancelled, ut plus half at square. This is S. So see, S equals to ut plus half at square, S equals to ut plus half at square. It has been derived. Now the third equation, v square equals to u square plus 2as. This we will start this using this equation. Equation 1 gives us v equals to u plus at. See, we have got v equals to u plus at. Now squaring both sides. We will get v square equals to u plus at whole square, or v square equals to, this is, we can use the formula a plus b whole square, because a plus b whole square equals to a square plus 2ab plus b square. We can use this formula here. So see, here a is u, this is a, and at is b. So a square means u square plus 2ab means 2 into u into at plus b square means at whole square, or v square equals to u square plus 2uat plus a square t square. This square will be for both a and t, so a square t square, or u square plus, let us take 2a common. We have written this u square. Now let us take 2a common from both these terms. So I have taken 2 and a. So left u and t is left. So ut is left after taking 2a common. So ut plus, there is no 2. So we have to give 1 2 in the denominator. 1a is already taken. There is a square, so another a will left, and t square. See, here from this term we have taken common 2a, so ut is left, and from here there is no t, so we have given there is no 2, so we have given 1 2 in the denominator. We have taken 1a as common, here is a square, so 1a will be left here, and t square. Or we can write u square plus 2a ut plus half at square. This is v square, or v square equals to u square plus 2a. See, ut plus half at square, ut plus half at square, that is from 2 we can write, in this place we can write as. So v square equals to u square plus 2as. We have written this as using equation 2. Using equation 2, we have written this. In place of ut plus half at square, we have written a's. So this is the third equation of motion. Say v square equals to u square plus 2as, and hence it is proved v square equals to u square plus 2as. And this is how the three kinematic equations of motions has been derived. No graph, no complications, pure logic. If you found this video useful, don't forget to like, share and subscribe. See you in the next video. Until then, keep learning and stay curious. Thank you.